Everyone, I am Krishak Ved, and today I'll be explaining you the standard model. It's a very key part in understanding particle physics and also high energy physics. So let us begin with it. Just a second. Uh, I think we went a little. Okay, just a second. So our first model about the standard model. Our first PPT presentation slide on standard model. What is standard model and what is it? So we'll be trying to understand it today. Unification of forces. We will have understanding all of this introduction what is particle physics. You all know about it, but still I'll explain it to those who are new to particle physics. And standard model is one of the most important parts, so it's mandatory. Particle physics and its questions. So particle physics is a study of those particles that are considered the building blocks of any matter or interactions between them. It's a study of building blocks, what particle, because they are considered the building. You have let's take this just as for example. We call particles because particles are making up each and every single thing. Solids made of particles tightly packed with each other. And just like this, we do everything. So the interactions between particles and build and about the particles, this is what particle physics aims to study through use. And we're going to do, yeah, here we go. Okay, so now let's move on to some questions. Are there fundamental constituents of matter in the universe? If so, what are they and what are their properties? What are forces and how are they transmitted? What is mass? What is antimatter? And where did it all go? And why does it tell what does this tells us about the origins of the universe and its fate? So these are some questions that drive this research. I think we have some problem. Just a second. No, we do not want this. Okay, now the standard model. Okay, just a second. Oh, no, 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 no. This slide, I want all of you to prepare this answer questions, and because yeah, this slide is not prepared by me. This is from Cornell University. Or I would love to see. I'm giving them credit. I'm not stealing their PPTs. It's just I was not able to make one in time. So what I would suggest you, I'm writing off my mail address over here. Just a second. Or just do one thing. Do not mail me. My mail address. You will find my mail address. Yeah, you will find my mail address in the description, and I will pin it in the comments below. Answer all of these questions, maybe in a notebook, maybe in anything. Click a photograph, attach those files, and send it to me on mail. And I would love to see what answers you people have created. Now let's move on. We have this problem once again. Okay. Particle physics answered question. We have done this, I guess. Okay, no, we have not done this. No, we have done this. Yeah, we were at the standard model. Yep. I think we are going back. Yep. Here, this is our third slide. We have done particle physics. Yep, we have done. I want the answers of these questions. Sorry, I was focusing over here. I want the answers for all of these questions. You can mail it to me. Now, the standard model. Make sure to mail it to me. I will drop it in the comments. What is it? People consider the best theoretical framework we have for particle physics. But once again, what is it? So, what does the standard model really mean? It's actually a unification of all matter into two types of particles. That is a unification of electromagnetic and weak nuclear forces, a description of the interaction between fundamental particles in terms of exchange of fundamental force particles. So, the standard model is the model that is actually currently the most required the accepted one. It explains as the unification of all matter into two types of particles. Two types of particles. What are those two types of particles? You all must know about it. Some things it does not do. It does not explain us about strong and electroweak forces. It ignores gravity. So means standard model does not is not actually the grand unified field theory (GUT). It does not unify. all the forces. Gravity is left out. It does not unify the strong and electro weak forces. Okay, because we need for solving the grand unified field theory, we need all of the four forces of the universe combined, or we could say, unify them, unified. But the standard model does not provide us with that. It does not explain why there are so. You must know there are multiple generations of so many particles. So it does not explain why there are so many generations of these particles, and it does not explain the disappearance of antimatter in the universe. Look, antimatter is something that have existed, but standard model is not explaining us where did all of this go. I don't know if you're getting my point. The unification of matter first attempt. So we have all of our elements here: water, we have air, we are going to unify the first attempt, unify air with water, fire, and earth. Then we have unification of forces, because of course we have the our unification processes in physics began from unification of matter, that was first aligning all of these. We call them, we do not call them forces, we do not natural laws, natural concepts such as air, fire, water, and earth. Then we have unification of forces where we unify electricity and magnetism, then we get electromagnetism. Then we add just a second, I will need a pen over here. So over here, a magnetism, electricity and magnetism. Wherever electricity is, we have magnetism over there too. Then they both combine electromagnetism, and when we combine light with it, we get Maxwell's electromagnetic theory. And then we have planetary motion and earthly motion that makes gravity, and space and time that makes general relativity. So gravity combines with space and time and all of this, and we have general relativity. So now what happens over here after we have weak nuclear force, and then we have strong nuclear force. So after we combine all of this and general relativity, so of course the combination of electromagnetism and uh, electromagnetic theory and weak forces and strong forces, weak forces, these both are combinable. We get electroweak theory. But once again, electroweak theory cannot be combined with a strong nuclear force. That's the biggest problem. That's why we do not have the grand unification. And if we get the grand unification, the final problem is to unify the gravity. We have general relativity with the grand unification. We need to unify the general relativity, Einstein's concept of classical mechanics, and grand unification. Of course, all of the which have been practiced, like quantum mechanics. Technically, quantum mechanics, we can say it. So, combination of quantum mechanics and general relativity is what we are missing today in our world. And by combining both of these, we would get a super unification. So we do not have super unification and grand unification. If we get grand unification, then we will easily be able to get super unification. But yet, we are not able to. I would like to actually say something wrong. We will not get super unification. We still need to find out. We do not have grand unification yet. Then we need to find out super unification. So grand unification would actually just easier our way, but we do not have grand unification. That's why quantum mechanics, strong nuclear force and weak nuclear force is not unified completely yet. Well, it is, but electroweak theory and strong force is not completely unified. That's what standard model is not able to tell us. And we do not have general relativity unified with grand unification, because grand unification does not exist yet. So let's move ahead. How are forces transmitted? Oh, sorry, just a second. Uh, mm, Go up. How are forces generally transmitted? So, in the 19th century, the force field was proposed. And in quantum mechanics, a particle associated with each force field transmits the force, our modern view. Because in quantum mechanics, we believe that a particle that is associated, for example, with any force, its field is actually transmitting the force around. So that was the place in the 19th century. That's how forces is transmitted according to quantum mechanics. Because, for example, if we believe this the particle with electric field force, so in its field, that's how it is transferring the electromagnetic force to the other particles. This is what happening with QM particles, particle Q and particle M. So this is what we have to take notice of. How do particles create forces? Okay. So for example, you threw a ball. Okay, you threw a ball. Ball is thrown upwards, and you're not catching the ball. This is what happens in electromagnetic forces. So, you see these particles, this is gamma. So, what is the, you can notice something similarity over here. The ball is thrown, and this ball is kicked, and this person over here is trying to catch the ball, and its movement, the ball towards movement is going from this section to, and it will go over this over here. Okay, and the one who's catching the ball, where we can assume it to be gamma radiation, so it is receiving it, and it was catching over here, it went as this, catches bowling ball, and he slides over here. You can see it over here too. So just believe, for example, electromagnetic forces. This gamma is actually the force that is being transmitted. This is the part of the force these particles are producing. This is a way. So this is how electromagnetic forces work. I hope you're getting everything. Have any doubts? Kindly comment or mail. Back to unification of matter. We have studied a lot. So yep, if we take a virus that is 10 to the power negative 7 meter, and we have something bigger than virus, smaller than virus, is a molecule that has a size of 10 to the power 9, that is 9 zeros ahead of 1 point. Look, how do I say it? I need a pen. Yep, I just need this. So, yep. I think you people all know it. 0.7 zeros and then 1. Okay, so this is what I was trying to do. So yeah, let's get back to the point. A virus is 10 to the power 7 meter. We need electron microscope to see it. Then we have molecule. Then we have an atom. A molecule is smaller than an atom is smaller than a molecule, and a nucleus is even smaller than an atom because it is in the center of an atom. Then we have a proton that is inside of the nucleus. And when we have inside the proton, we have quarks. You up quark, down quarks. You must have studied quantum chromodynamics. Researchers must know about all of this. Well, this is quite basic things. But now our question is, what is smaller than a quark? See, what is smaller than a quark? That's my question from you. If you are a string theorist, you will say we have strings. If you're a quantum loopist guy, you will say we have loops. It depends. Okay, so if we have, look, just a second. The fundamental particles of nature. So matter particles are generally have the spin of 1 by 2. For example, leptons have the charge of -1 and 0, up and -0, and quarks have positive 2 by 3, and down quarks, okay, at the sequence have the charge of -1 by 3. Okay, just a second. Yeah. So okay, plus n-type particles. Do we have some problem? So force particles that we have bosons. So the integer spin is, for example, if they have strong nuclear force, their intrinsic strength is to be 1.0. The boson is gluon. The symbol is G. Mass is 0. Charge is 0. Spin is 1. Then we have electromagnetic, that intrinsic strength is 1 by 137. And the boson that we have over here is photon, the massless particles, because of electromagnetic, you should get it. Uh, Okay, so the boson for strong for gluon, and electromagnetic we have photon. The symbol is gamma, and we have mass of 0, charge of 0, spin of 1. Then we have weak electromagnetic force. Then we have intrinsic strength of 10 to the power -9. Boson is weak boson. And we have a symbol of V plus or minus, V to the power plus or minus, or Z naught, Z to the power 0, sorry, Z to the power 0. Its mass is 100 GeV, and its charge is plus or minus E or 0, and its spin is 1. We have a gravitational, then we have the gravitational force. Its intrinsic strength is 10 to the power 38. The boson for it is graviton. Graviton are not discovered yet. So the symbol is G, mass is 0, charge is 0, spin is 2. 1, the value of 1 ev is equals to 10 to the power 9 ev, that is mc squared of the proton. Okay, just a second. Just a second. Okay, it's not working again. Okay, I am okay. We have here. So we have some diagrams, electromagnetic force that I just explained to you. Then we have strong nuclear proton. The core is equal to G. This is gluon. Okay. We have this strong nuclear proton over there. Then over the next slide we have okay. So we are the uncertainty principle because we're not able to determine. So for over the first we have uncertainty principle. So that's why we are unable to determine both of them at the same time. You can see some things over here. Yup. Yup. Okay. So this is what we get. So beta decay for this is equals to n, that will be equal to p plus e minus plus v. It is. Then we have electroweak unification for electromagnetic, and this is for the weak nuclear. At energies that are greater than 100 GeV, the z to the power 0 and photon can be equally produced. That is, the two phases act as the same one. Okay, so then we have the annihilation. Okay, just a second. This is stuck over here, I guess. Annihilation and creation. In annihilation, that is removing of it, this is how it goes, because the gamma radiation, both of these in negative and positive, they both turn into gamma annihilated. They get both annihilated and turn to gamma. In creation, you can see the difference is notable. Thus should be able to produce new in the E minus E negative positive annihilation, for example this one. So this explains how the annihilation of both of them should be producing the should be creating the new negative new positive. Okay. Okay. So from annihilation of both of this, for annihilation of this should be creating new it up over. I think it's not working again. Or the annihilation of E negative E positive gamma radiation transmission should be creating Q negative and Q positive. So E negative plus E positive, that is greater than 2mc squared. Okay, so this is the moment of the creation. I will not be explaining much of this. So this is how it goes from 10 to the power 10 years. Then we have 300,000 years and 3 minutes and 10 to the power okay, so I'm actually going so 10 to the power negative 43 seconds, 10 to the power negative 35 seconds, 10 to the power 10 seconds. This is what we have. Mm, I think the slide's over. So thank you for participating. If you have any questions, kindly send it to me. Goodbye.